Hello everyone. In this video, let us study about continuous random variables. Let us discuss how to find CDF and PDF for a given continuous random variable. Before we look into the general features of PDFs and CDFs, we should know that CDF is always assumed to be a continuous function, except there exists the derivative of fx of x for finite number of points. Let us look into the features of PDF and CDF. CDF, that is probability density function, can never be negative for any value of its independent variable. That is, f of x, fx of x is always positive, greater than or equal to 0. When x equal to minus infinity, CDF value is 0. When x equal to plus infinity, integral of the PDF function with respect to x between the interval minus infinity to plus infinity is always equal to 1. That is, the area under the PDF curve is always 1. Probability of x value between x1 and x2 can be found out using the CDF function. That is, fx of x2 minus fx of x1. That is equal to integral of the PDF function fx of x between the interval x1 to x2. The area under a PDF curve over a specific interval in SF, even space, is the probability of observation of a random variable occurring in that interval. Let us look into the fifth feature of CDF and CDF. A useful approximation is probability of x value varying between x and x plus delta x is the integral of fx of u du between the interval x to x plus delta x, that is equivalent to fx of x into delta x. If this delta x tends to 0, then the probability that a random variable always equal to 0. That is, c of x equal to x integral of x2 minus x to x fx of u du is equal to 0. For any random variable with continuous CDF, give some flexibility in the use of equality and inequality as indicated here. The CDF fx of x is equal to probability of x less than or equal to x is equal to the probability of x equal to x plus probability of x less than x. That is equal to probability of x less than x. With few examples, let us try to understand the procedure involved in calculating the CDF and PDF of a given continuous random variable. First example, calculating the probability from the probability density function. If a random variable has the probability density function fx of x equal to 2 e to the power minus 2x for x greater than 0, find the probability that it will take on a value a between 1 and 3, e greater than 0.5. E also find its CDF function. First one, between 1 and 3. We need to integrate the probability density function 2 e to the power minus 2x with respect to x between the interval 1 to 3. When we do it, we get the value as 0.133. Second one, b greater than 0.5. That means the interval will be from 0.5 to infinity. So we need to integrate the probability density function with respect to x between the interval zero point 0.5 to infinity, we get this as 0.368. Then the cumulative distributive function fx of x can be obtained using, it is always 0 for all values of x less than or equal to 0, and by integrating the probability density function 2e to the power minus 2t dt between the limits 0 to x, we get it as 1 minus e to the power minus 2x. It is valid for all values of x greater than 0. Even though if we consider x equal to 0, you know that this is going to be 1. 1 minus 1, it is going to be 0. You can observe here it is 0. So you can calculate for any value of x. So if you substitute x value is equal to 1, then fx of 1 is equal to 1 e to the minus e to the power minus 2, that will give you 0.865. That is how we can calculate CDF. Start with the second example. A probability density function assigns probability 1 to between minus infinity to infinity. We need to find the value of k so that the following can serve as the probability density function of a random variable. The probability density function is given here. We know that this cannot be a negative value. However, this is 0 here for all values of x less than or equal to 0. For x greater than 0, if this has to be a positive number, then k has to be a positive number. K should be a non-negative value. Now let us try to find out the value of k using the formula. We know that the integral of CDF function is always equal to 1, and it is minus infinity to fx of x dx, but we know that we have been defined k into x e to the power minus 4x square for all values of x greater than 0, that is from 0 to infinity. Let us integrate this. Let us put this 4x square is equal to u. When we put this, du is equal to 8x dx. Let us make the substitution. We get this as k by 8 e to the power minus u du under the integral sign. This is equal to k by 8, that is equal to 1. So therefore, we get the value of k is equal to 8. Let us try to get CDF from the PDF. We take an example here. The CDF of the PDF given. This CDF is defined for a uniform random variable, and it is graphically, it can be shown as fy of y is value is equal to 1 between y1 to y2. So therefore, fy of y CDF function is defined as 1 divided by y2 minus y1 for all values of y between y1 to y2. Otherwise, it is 0. Let us try to find out cumulative function fy of y for all the values interval of y varying between y1 to y2. It is anywhere between y1 to y2. This can be obtained by integrating 1 divided by y2 minus y1 dy. This value varies from y1 to any value y. So that gives you y minus y1 divided by y2 minus y1. For all values of y greater than y2, that is from y2 infinity, fy of y is given as 1. So therefore, fy of y, that is CDF, is defined as 0 for all values of y less than y1. Fy of y is defined as y minus y1 divided by y2 minus y1 for all values of y between y1 to y2, and it is 1 for all values of y greater than y2. Let us look into the requirement for a continuous CDF and its associated CDF. That means characteristics of a continuous random variable. CDF should be non-negative. It should never be less than 0. The area under the curve is always 1. CDF is also continuous. It varies from 0 on the left to 1 on the right in the case of previous problem. The derivative of CDF exists everywhere except at boundary. We will take the previous problem. Fy of y is defined for the uniform random variable, and this is the plot of Fy of y versus y, and we have calculated Fy of y and we have plotted here with respect to y, and we have got between y1 to y2 its value varies, and the formula is y minus y1 divided by y2 minus y1, and at y equal to y2 its value is going to be 1, and it remains 1 for all values of y greater than y2. Only during this period its value will change, and it is given by y minus y1 divided by y2 minus y1. So at y is equal to y1, its value is going to be 0. At y is equal to y2, its value is going to be 1. And you can observe here, and it is a continuous function. Let us solve a problem here. Fx of x is given to us. It is defined as 1 minus e to the power minus x square by 4 for all values of x greater than or equal to 0, and it is 0 otherwise. We need to evaluate the probability of x values varying between 1.1 to 2.1. So let us calculate the CDF at 2.1, that is using this equation, and try to subtract the CDF calculated at 1.1 using this equation. So we have 0.2610 minus 0.6679, that will give us 0.4069. Thank you. In the next video, let us study mixed random variables.